If I wonder what makes neural networks so powerful, it's about the activation functions. The activation function are, let's say, the secret that give the neural network the decision-making power. So in this video, I will try to, let's say, to show you three important activation functions you need to know: Sigmoid, Tanh, and ReLU. So by end of this video, you will have the chance to choose the right activation function for any neural network, and also answer the questions in the interview confidently. So let's start. So first, what exactly are activation functions? So imagine you are a neuron in a neural network. So you will receive a signals, do some math, and then need to decide whether to fire or not, whether let's say to activate or not. So that's where the activation functions come in. So they are like a decision makers of the neural network. So without activation function, our neural network would be, let's say, assembled like linear regression models. So and uh, activation functions add, let's say, non-linearity magic to the network that allows neural network to learn a complex pattern and also solve real world problem. So as I said, without activation functions, it will be as the linear regression. So let's see here we have three different activation function: the sigmoid function, Tanh, and ReLU. And the sigmoid function, it's used for binary classification. Why? So if you have a deep neural network, you will not be use it in the hidden layers as, for example, the activation function, because it's vanishing gradient. What does the vanishing gradient means? See, if you have forward propagation and updating the weights, called a back propagation. So after calculating the gradient, I have also explained this in one video. I will put the description in the link in the description. So after calculating the gradient, some gradients will be close to zero if we use the sigmoid function. So if the weights, or let's say gradient, are close to the zero, the update of the network, it will be, let's say, first, or it will need not updated anymore. And the tan edge, it's used for hidden layers, and it's used for zero centroid if you would like to have the data zero centroid. And also it has a vanishing gradient. And for the ReLU, its most use cases we have, uh, I have always see in the in any, let's say, neural network, they use ReLU, which is useful for the deep network. So if you see here, the range is 0 and 1 for the sigmoid, and here -1 and 1, and here from 0 to infinity. So you have the give the network to learn and not vanishing, because you have from 0 to infinity. And the house work, it's like taking just the max for 0 or x. So it means it will ignore the negative values. And here it will calculate this tonnage, and this is calculating the sigmoid formula. And here, which activation function should you use? So if you see here, this is the range, and vanishing gradient is for the sigmoid and tannage. And for the vanishing gradient, it's no for a ReLU, because as I said, it has the probable range from 0 to infinity. So the weight won't be, let's say, the gradient won't be, let's say, 0. Uh, and also zero centroid, here is only the tan edge. And the complexity, the most, let's say, it's not complex, it's just taking the maximum, which is very low. So when to use sigmoid, it's just only used for binary classification. So when you would like to have the probability between 0 and 1, if you have, let's say, to classify an image in a dog or cat, and let's say you'll have a probability, let's say, 0.5, or let's say point 0.3, point 0.9, point something, and you will have after that you will have a specific threshold, and if the probability is greater than this threshold, it will be classified as this class. If not, it will be the other class. So, and try to avoid, I mean, not try to avoid, don't use sigmoid in hidden layers because it's vanishing gradient. And for the tannage, it's used for hidden layers, but also we see it's a zero centroid centered output, but also we still suffer from gradient, vanishing gradient. But try always use ReLU when you have a deep neural network. In the hidden layers, it will use you will use ReLU. After convolution and polling and this, you will have a reactivation function with ReLU. And we have said that the activation function in general, as let's say it's the adding complexity or non-linearity to the network to learn complex data. So I think that's it for today. If you have any question, just drop it down in the comment below. I will definitely answer it. Thanks for watching.